Alright guys, this video is on polynomial division. And before we do polynomial division, I want to review just good old-fashioned long division. So let's use long division to find 39,617 divided by 28. Okay, so if you remember from elementary school, you put the 28 here, and then you draw this little house, and then you put the numerator, 39,617, under the house. And then you think. First you want to say, well, 28 goes into 39 how many times? It goes in there one time. So you put a 1 right here. And then you multiply. 1 times 28 is 28. And after you multiply, you subtract. You go 3 minus 2 is 1, and 9 minus 8 is 1. Right? 39 minus 28 is 11. And 28 doesn't go into 11, so we bring this 6 right here down, and we bring it down, 1/16. And then we say 28 goes into 1/16 about how many times? And we think, well, maybe 4 times. So we write a 4. So we will multiply. 4 times 8 is 32. Bring the 3 up here. 4 times 2 is 8, plus 3 is 11. So 28 times 4 is 112, and we will subtract. Alright, so 1 minus 1 is 0, 1 minus 1 is 0, 6 minus 2 is 4. Then we will bring down this 1. 28 goes into 41 only one time, so we write a 1 and we multiply. 1 times 28, and we subtract. 41 minus 28, that's going to be 13. And I'm running out of room here, but we would bring down the 7, so now I'm going to go up here. I'm just going to write my 137. So 28 goes into 137 how many times? Well, we know it went into, well, it was 112 4 times, and if you added 28 to 112, it would be more than 137, so I'm going to go with the 4. And 4 times 28, which we already know is 112, and we subtract, and we get 25. So 25 is our remainder. And back in the old days, you used to just write R25. So 28 goes into 39,617, 1,414 times with a remainder of 25. And if you wanted to do this as a fraction, you would say 1,414 and 25 28ths. 25 28ths. So this is what you would multiply by 28 to get 39,617. So now let's try it with a polynomial. We've got x squared plus 3x plus 5 divided by x plus 1. So we're going to put the denominator on the outside. X plus 1 can go here with our house. And x squared plus 3x plus 5 can go here. And now, instead of looking at the whole x plus 1, we're just going to look at the first term, the x, and we're going to look at the first term here, x squared. X goes into x squared how many times? And x goes into x squared x times. X times x is x squared. So I'm going to write an x here, and I put it here because this is where all the x's are going to be lined up vertically. So now I multiply, and I multiply it by both. I'm going to do x times x and x times 1. So I have x times x is x squared, and x times 1 is 1x. And then, just like when we were doing old-fashioned long division, we're going to subtract. Make sure that you put parentheses around this and subtract the entire thing. So x squared minus x squared is nothing, and 3x minus 1x is 2x. And then we're going to bring down the plus 5. Oh, and yes, that was my insane husband in the background right there. So yeah, and I told him I'm leaving it. I'm not going to delete it out of the video. You all can hear what a moron he sounds like. Alright, so where was I? X times x is x squared. Okay, so we're subtracting. So now we need to bring down the 5, plus 5. And then we're going to repeat the process. So now we say x goes into 2x 2 times, and I'm going to put plus 2, positive 2, and I'm going to multiply the 2 times the x and the 1, and I have 2x plus 2. Then we will subtract the whole thing, and we have 2x minus 2x is nothing, and 5 minus 2 is 3. There's nothing left to bring down, and x doesn't go into 3. Ugh. See, this is what happens when I make the videos at home on the weekend. Alright, so the 3, that's our remainder. But we don't put remainder 3 because we're not in 3rd grade. We're going to put plus 3 over x plus 1. That x plus 1 I got from here. Alright, so that's how you divide polynomials. Okay, so now let's do this one. Doesn't that look like fun? We're going to take the denominator, x squared plus 2x minus 3 on the outside, and we'll put the polynomial on the numerator, 2x to the 4th plus 4x to the 3rd, minus 5x squared plus 2x minus 3, all in the house. But remember, we just look at the first term in the first term. So what would we multiply x squared by to get 2x to the 4th power? And the answer is 2x squared. So I'm going to put 2x squared all the way over here in the x squared column. Then we multiply it times all 3 pieces. So 2x squared times x squared is 2x to the 4th. 2x squared times 2x would be positive 4x cubed. And 2x squared times negative 3 would be minus 6x squared. And we are going to subtract this entire line. So we have 2x to the 4th minus 2x to the 4th is nothing. 4x cubed minus 4x cubed is also nothing. And then we have negative 5x squared minus negative, so plus 6x squared, and that gives us 1x squared. Alright, so now we're going to bring down the 2x, the plus 2x. However, we also have to bring down the minus 3. Because we have 1, 2, 3 terms here, we need 3 terms for it to go into. So now if you look, x squared plus 2x minus 3. X squared plus 2x minus 3. We're going to say x squared goes into x squared 1 time. So I'm going to put my positive 1 over here. And then I'm going to multiply everything by 1. X squared plus 2x minus 3. And subtract it all. And when I do that, I have nothing left. I have no remainder. So what that means is that x squared plus 2x minus 3 times 2x squared plus 1 equals that on top. So basically, we just factored it down a step using long division. Here would be the answer if you were just asked to divide. So now we'll do one more just for good measure, and I wrote it differently. I wrote it with a little division symbol. Nothing different about that. So we're going to put what we're dividing by on the outside, x squared minus x minus 2, into x cubed plus 3x squared, and I picked this one because I don't have an x term. And just like when we were doing the vertical adding and multiplying and stuff, we need a spot for it. So we have to have plus 0x and then minus 7. You have to have that spot. So now we can say x squared goes into x cubed x times, and we put it there. See, if we hadn't left that spot, we wouldn't have anywhere to put the x. And we multiply x times x squared is x cubed. X times negative x is negative x squared. X times negative 2 is negative 2x. And we're going to subtract the entire line. So x cubed minus x cubed is nothing. And this is where people are always forgetting to distribute that negative sign. We're doing minus negative x squared. So we're adding x squared. So we have 4x squared. And then I have 0x minus negative 2x. So we're adding 2x. And then we'll bring down the minus 7. Alright, so we repeat. X squared goes into 4x squared, positive 4 times. And we multiply. 4 times x squared is 4x squared. And 4 times negative x is minus 4x. And 4 times negative 2 is minus 8. So we're going to subtract the entire line. We get nothing. 2x minus negative 4x would be 6x. Negative 7 minus negative 8 would be plus 1. And x squared doesn't go into 6x, so this is our remainder. This is our answer, and then we say the answer is x plus 4 plus our remainder, 6x plus 1, over our divisor that we were originally dividing by, x squared minus x minus 2. That's the final answer. Yeah, that's my dog. Alright, so that was long division of polynomials. Now I'm going to teach you how to do synthetic division of polynomials. And it's just like synthetic substitution that we learned a few days ago. However, it can only be used when the divisor is x plus or minus a number. Alright, so when you are dividing by x plus or minus a number, you can take that number and you're going to take the opposite of that number, because if x minus 3 was a factor, then x would equal 0 at 3. So you take the opposite of that number, 3, and then you make this box, make it 2 lines deep, just like with synthetic substitution, and we're going to put a 1 for the x to the 4th. We don't have an x cubed, so we're going to put a 0. We have a negative 10, a 2, and a 3. And then the process is exactly the same. We're going to bring down the 1, and we're going to multiply. 3 times 1 is 3. Then we're going to add 0 plus 3 is 3. And we're going to multiply. 3 times 3 is 9. Then we're going to add. Negative 10 plus 9 is negative 1. And then we're going to multiply. 3 times negative 1 is negative 3. 2 plus negative 3 is negative 1. 3 times negative 1 is negative 3. And 3 minus 3 is 0. Now, when you're doing division, synthetic division, if you have a remainder of 0, that's great. That means it divides evenly. So x to the 4th minus 10x squared plus 2x plus 3 divided by x plus minus 3 equals, you take each of these numbers down here and they become the coefficients for your answer, and your answer will always be 1 power less than what you started with, because we took x to the 1 into x to the 4. So we start with 1 x to the 3. And then we have plus 3x squared. And then we have minus 1x. And then we have minus 1. You always go 1 power lower than what you started with, because you're only dividing 1 into it. And so that's our answer, with no remainder this time. If you had a remainder, you would write it over the divisor just like you did in the past. Okay, let's do another one. Let's divide 2x cubed plus 9x squared plus 14x plus 5 by x minus 3. I don't know why I chose x minus 3 again for this one, but that's okay. We'll take a 3, make the box. We have 2x cubed, 9x squared, 14x, and 5. So we didn't need to add any zeros this time. We'll bring down the 2. 3 times 2 is 6. 9 plus 6 is 15. 3 times 15 is 45. 45 and 14 is 59. 3 times 59 is 177, and 5 plus 177 is 182. So this time we do have a remainder. So we would write this answer. This 2 comes first, and then since we started with cubed, we'd have squared in our answer. Plus 15x plus 59 plus the remainder, 182, divided by my moron husband again, x minus 3. Okay, so all this division brings us to what we call the factor theorem. And the factor theorem states that a polynomial f of x has a factor x minus k if and only if f of k equals 0. Because remember when we did synthetic substitution, and you plugged in a number, then you found out what it equaled by the last number, which is, we now know, our remainder. If you have a remainder of 0, it divides in perfectly. And if it divides in perfectly, then that means that x minus k is a factor. So the factor theorem can be used to solve several types of problems. We can use it to factor big, gigantic polynomials. Because if I know at least one other factor, I can find the other factors. Or if I know a 0, then I could find the other zeros. Or if I know a solution, which is kind of the same thing as a 0, then I could find the other solutions. So here's a problem for you. Factor f of x equals 2x cubed minus 11x squared plus 3x plus 36 completely, given that x minus 3 is a factor. So all I'm saying is I'm taking this polynomial and dividing it by that polynomial, because a factor is something that divides into it. And so I'm going to do the division and figure out what I multiply by this to get this. See? So I take the big polynomial equals x minus 3 times what? So I'm going to divide it. And you can use long division or synthetic. I'm going to use synthetic just because we just learned it, and for some reason I just like the 3's today. I don't know why. We'll take that 3 and divide it in. We've got 2x cubed minus 11x squared plus 3x plus 36. I'll bring down the 2. 3 times 2 is 6. Negative 11 plus 6 is 5. See that beeping? That's my cookies are ready. I'm telling you, these making videos at home thing is just not working for me. Peanut butter cookies, my favorite. Okay, so now we'll continue this problem. And this should be a negative 5, actually. Negative 11 plus 6 would be negative 5. 3 times negative 5 is negative 15. 3 minus 15 would be negative 12. And 3 times negative 12 is negative 36. So that gives us a remainder of 0. Hallelujah, it works out perfectly. 2x cubed minus 11x squared plus 3x plus 36 is equal to x minus 3 times question mark. Our question mark we now know is 2x to the second power. I know it's second power because it's 1 less than third power. Minus 5x minus 12. And then you look at it and you say, could I possibly factor this any further? And unfortunately, yes, you can, because you can factor this. I'm not going to go through all of that to save time, but you can factor it. You get 2x plus 3 and x minus 4. So we have now just factored a cubic polynomial by hand using synthetic division. Okay, one more. Given f of x equals 2x cubed plus 11x squared plus 18x plus 9 has x equals negative 3 as a 0, find the other zeros. So see, I could give you this crazy polynomial, and I might let you use a graphing calculator, and so you could put this into y equals. And you would see the weird looking polynomial, and you might be able to estimate where does it actually equal 0. And so suppose negative 3 looks like a perfect 0. So you'll take negative 3. And we'll make the box. Now remember, if I said my factor was x minus 3 like I did in the past, I don't know, 3 problems, then I used a positive 3 when I was doing my division. But I'm saying x equals negative 3 is the actual 0, so I'm using the negative 3. You put the 0 here. So I've got 2x cubed, 11x squared, 18x, and 9. And I'm sure you can hear my kids. They're screaming outside. Don't worry, my mom's with them. And my moron husband. Alright, bring down the 2. Negative 3 times 2 is negative 6. 11 minus 6 is 5. Negative 3 times 5 is negative 15. 18 minus 15 is 3. Negative 3 times 3 is negative 9. And 9 minus 9 is 0. So it does divide evenly. If this had been anything other than 0, then x equals negative 3 would not be a 0. So we would have either been wrong or we would have done our division wrong. So we are trying to find the other zeros. We know that factored it would be x plus 3, and then 2x squared plus 5x plus 3, which we can use our fabulous factoring skills to factor further now by hand, because once you get it to a quadratic, you're expected to be able to do that by hand. So we have 2x plus 3, and we have x plus 1, saving you some time, unless you just want to work through all that factoring. But we're looking for zeros, and when you're looking for zeros, that means you set each factor equal to 0 to find out what would make each one 0. And our zeros are x equals negative 3, which they told us, and x equals negative 3 halves, right? Set that equal to 0, subtract 3, divide by 2, and x equals negative 1. And so now we know all the zeros, and there's 3 of them, and it's a cubic function, so that works out. And that's it. We're done. Except for this, and I know this is multiplying, foiling instead of factoring, but they're related, so yeah, whatever. Although I think my husband's little cameo appearances in this video are probably funnier than this. Alright, well, I'll see you tomorrow. Have a good night.